There is a moment you keep returning to. Maybe it happened years ago, maybe it happened last week. A conversation that went wrong. A failure that still stings. A humiliation so precise and specific that you can still feel the exact temperature of the room when it happened. You have tried to move on. You have told yourself it does not matter anymore, and yet your brain pulls you back. Again and again. Like a tongue finding a sore tooth, you are not broken, and you are not weak. The real reason your brain refuses to let go of painful memories is far stranger than you think, and it reaches back further than you can imagine. Your memory is not a recording device. This is the first thing you need to understand. It does not store events the way a camera stores footage, neutral and complete. It stores meaning, it stores threat, it stores the emotional weight of what happened, and uses that weight to decide what gets remembered clearly and what gets allowed to fade. Your brain is not trying to preserve your history. It is trying to keep you alive. And to do that, it has developed a system so powerful and so ancient that it operates almost completely outside your conscious control. The system begins in a small almond-shaped structure buried deep inside your brain called the amygdala. Neuroscientist Joseph Ledoux spent decades mapping the amygdala's role in emotional memory at New York University, and what he found changed the way scientists understand fear and survival. The amygdala, Ledoux showed, acts as the brain's threat detector. It receives sensory information faster than the conscious cortex can process it, and immediately begins tagging incoming experiences with emotional significance. Before you have even finished processing what is happening, your amygdala has already decided whether it is dangerous. And if it decides something is dangerous, it sends a signal that floods the brain and body with stress hormones, cortisol and norepinephrine, that dramatically enhance the encoding of that memory. This is why you remember your most painful experiences in extraordinary detail. The lighting, the words used, the expression on someone's face, the sound of the door closing. Stress hormones act like a chemical highlighter, burning the details of threatening experiences into long-term memory with a precision that ordinary pleasant experiences almost never receive. Your brain is not being cruel when it holds on to pain. It is doing exactly what it evolved to do. Think about the world your ancestors navigated 100,000 years ago. A world with no hospitals, no police, no safety nets of any kind. A world where a wrong decision, trusting the wrong person, wandering too close to a predator's territory, eating the wrong plant, could end your life before nightfall. In that world, forgetting a dangerous experience was not a minor inconvenience. It was potentially fatal. The human whose brain let go of painful memories too easily did not survive as reliably as the human whose brain burned them in permanently. The pain of memory was not a side effect of human consciousness. It was a survival feature, selected for and refined over hundreds of thousands of years of living in a world that punished carelessness with death. Researchers have a name for this mechanism. They call it the flashbulb memory effect, a term coined by psychologists Roger Brown and James Kulik in 1977 after studying why people retained such vivid memories of shocking public events. Brown and Kulik found that emotionally intense experiences, particularly those involving surprise, personal relevance, and a sense of consequence, were encoded with an unusual level of detail and durability compared to ordinary memories. The brain, they theorized, essentially took a snapshot at the moment of high emotional arousal, preserving not just the event but the sensory context surrounding it. Later research refined this model, showing that while flashbulb memories feel more accurate, they are not necessarily more factually correct than ordinary memories. But they are more durable, more resistant to fading, and far more likely to be retrieved spontaneously. That last part is important. Spontaneous retrieval. The memory that surfaces without you choosing to access it. The intrusive recollection that appears while you are doing something completely unrelated. Washing dishes, trying to fall asleep, sitting in a meeting, and pulls you immediately back into the emotional reality of a moment that happened months or years ago. This is not a malfunction. This is your brain running a diagnostic. It is checking whether the threat that encoded that memory has been resolved, whether the danger has passed, whether the lesson has been learned. Because here is what your brain does not understand. It does not have a timestamp. It cannot distinguish between a threat that existed 3 years ago and a threat that exists right now. When your amygdala retrieves a painful memory, it does not retrieve it as history. It retrieves it as present. The stress hormones fire again. The body responds as if the danger is current. Your heart rate changes. Your muscles subtly tighten. Your attention narrows. And this is why painful memories feel so immediate, no matter how long ago they occurred. Your nervous system is not revisiting the past. It is experiencing it. Neuroscientist Bessel van der Kolk documented this process in extraordinary depth in his research on trauma and the body. Van der Kolk showed that traumatic memories are stored differently from ordinary memories, not as coherent narrative, but as fragments. Sensory pieces, a smell, a sound, a physical sensation. These fragments are held not just in the brain, but in the body itself, in the patterns of muscle tension, in the regulation of the breath, in the activation state of the nervous system. When something in the present environment resembles one of those fragments, a tone of voice, a particular quality of light, a physical sensation, the brain does not say this is similar to what happened before. It says this is what is happening now. And the full emotional force of the original experiences floods back. This is why certain smells can transport you instantly to a memory you had not thought about in years. This is why a particular song can make your chest tighten before you have even consciously identified what you are feeling. Your brain has associated those sensory details with an emotionally significant experience, and it retrieves them together as a package, automatically and involuntarily. But here is the part that changes everything. Memory is not fixed. This is one of the most important discoveries in modern neuroscience, and it comes from the work of researcher Karim Nader at McGill University. Nader's research, conducted in the early 2000s, demonstrated something that contradicted decades of scientific assumption. Every time you recall a memory, you do not simply replay it, you reconstruct it. And during that reconstruction, the memory becomes briefly unstable, what neuroscientists call labile, meaning it is temporarily open to modification before it is stored again. This process is called reconsolidation, and it means that the act of remembering is not passive, it is creative. Each time you access a painful memory, you are rewriting it slightly, layer by layer, shaped by your current emotional state, your current beliefs, your current understanding of what happened and why. This is why the same event can feel devastating at one point in your life and almost neutral years later. Not because the facts changed, but because the meaning changed. And meaning is what memory stores. Now consider something even more unsettling. The memory you are holding on to right now, the one that surfaces at 2 in the morning, the one that makes your stomach drop when something accidentally reminds you of it, that memory is not accurate. Not entirely. Research by psychologist Elizabeth Loftus at the University of California, Irvine, spanning more than 4 decades, has demonstrated something deeply uncomfortable about human memory. It is not a fixed archive. It is a living, breathing, constantly updating construction. Loftus showed in hundreds of experiments that memories can be altered, implanted, and distorted simply by the way questions are asked, by the information introduced after an event, by the emotional state of the person doing the remembering. People can be led to remember things that never happened. They can be convinced that details were present that were not. And they will remember these fabricated elements with complete confidence, with the same subjective certainty they bring to things that genuinely occurred. What this means for your painful memories is significant. The version of events stored in your brain is not the raw footage of what happened. It is an interpretation. It is a reconstruction assembled from sensory fragments, colored by the emotional state you were in at the time, filtered through every belief you held about yourself and other people, and then reassembled slightly differently each time you recall it. The person who hurt you may have been less intentional than your memory insists. The moment of humiliation may have been less visible to others than it felt from inside your experience. The failure may have been less catastrophic than the story your brain has been telling you ever since. This does not minimize what happened. It does not make the pain less real. But it does mean that the memory you have been treating as an objective record of truth is, in fact, a story your brain constructed and has been reconstructing every single time you have returned to it. There is another dimension to this that almost nobody talks about: the role of sleep. When you sleep, your brain does not simply rest. It processes. It consolidates. It selects which memories from the day get transferred from short-term storage in the hippocampus into long-term storage in the cortex. And this selection process is not random. It is weighted. Emotionally significant experiences, particularly negative and threatening ones, receive preferential treatment during sleep consolidation. They get replayed, strengthened, linked to related memories from the past. Researcher Matthew Walker at the University of California, Berkeley, has documented how REM sleep in particular plays a critical role in emotional memory processing, not just storing emotional memories but stripping away the raw emotional charge attached to them over time, allowing the brain to retain the information while softening the pain. Here is the cruel irony. The very experience of lying awake at night, replaying a painful memory, disrupts the REM sleep that would eventually help your brain process and metabolize that memory. The rumination that feels like your brain trying to solve the problem is actually preventing the neurological process that would begin to resolve it. You lie awake. The memory intensifies. The sleep that would help does not come. And so the cycle continues, night after night, the memory growing more entrenched, not because it is more important, but because it is being rehearsed without resolution. Your brain also has a negativity bias that amplifies all of this. Psychologists Paul Rosen and Edward Roisman established through extensive research that negative events, negative emotions, and negative information have a greater effect on psychological states than equally intense positive events. This is not a personality flaw. It is a universal feature of human cognition. Bad is stronger than good. A single painful interaction leaves a deeper impression than multiple pleasant ones. A single failure weighs more heavily in memory than multiple successes. The brain, calibrated for survival rather than happiness, treats negative information as more valuable and more urgent than positive information. Because in the ancestral environment, the cost of ignoring a threat was death. The cost of ignoring an opportunity was merely a missed meal. And so your brain runs this calculation constantly and unconsciously. It inflates the significance of painful memories. It returns to them more frequently. It encodes them more deeply. Not because something is wrong with you, but because your brain is running ancient software in a modern world, applying Savannah logic to an office meeting, a social media comment, a relationship argument. The stakes it assigns to these experiences do not match the actual danger they represent. But the brain does not know that. It only knows what the amygdala told it. And the amygdala does not deal in nuance. So what do you do with all of this? How do you work with a system this ancient and this powerful? The first thing is to understand that the goal is not to erase the memory. You cannot. And even if you could, you would not want to. The memory contains information. It contains something your brain decided was important enough to preserve at significant metabolic cost. The goal is not erasure. It is integration. Moving the memory from a raw, open wound that the brain keeps returning to check on into something closer to a scar. Still there, still part of you, but no longer bleeding. The reconsolidation research offers a remarkable possibility here. Because every time you recall a memory, it becomes briefly unstable. There is a window, narrow but real, in which the memory can be updated. Therapies built around this understanding, including approaches like EMDR, which stands for eye movement desensitization and reprocessing, work precisely by activating a painful memory while simultaneously engaging the brain in a bilateral sensory task, disrupting the re-storage process in a way that allows the emotional charge attached to the memory to be reduced without erasing the factual content. The memory is accessed, the reconsolidation window opens, and new information, safety, context, understanding, gets written into the memory before it closes again. This is not magic, it is neuroscience. Your brain, the same brain that encoded the pain, contains the mechanism for metabolizing it. The system that held the memory hostage also holds the key. And there is something else, something simpler and more immediate. The act of understanding why your brain does this changes your relationship to the experience of it. When a painful memory surfaces unbidden at 3 in the morning, and you know, really know, at a neurological level, that your amygdala is running a threat detection protocol, that your stress hormones are firing in response to a past danger that no longer exists, that the memory feels present because your brain has no timestamp, that what you are experiencing is ancient software doing its ancient job in a world it was never designed for. Something shifts. Not immediately, not completely, but the experience of being ambushed by a memory is different when you understand what the ambush actually is. You are not weak, you are not haunted, you are human. And your brain is doing exactly what 300 zillion years of survival pressure built it to do. Your brain holds on to painful memories because it loves you in the only way it knows how. It is trying to protect you from repeating an experience that once registered as dangerous. It is running the same program your ancestors ran on the savannah. The program that said, remember this. Remember exactly this. Because the next time it happens, you will need to be faster, smarter, more prepared. The problem is that the program was not designed for the complexity of modern pain. It was not designed for social humiliation or professional failure or relationship betrayal. It was designed for physical threat, for predators, for poison, for the sudden violence of a world without walls. And so it applies the same intensity, the same chemical urgency, the same refusal to let go to experiences that are painful but not lethal. It cannot tell the difference between a lion and a cruel word said at exactly the wrong moment. It treats both as survival information. So tonight, when that memory surfaces again, the one you have been trying to outrun, understand what is actually happening. Your brain is not punishing you. It is not broken. It is doing something ancient and precise and, in its own terms, completely logical. It is holding the memory open because it has not yet received the signal that the threat is resolved, that you are safe, that you survived. You did survive. You are here. And the part of you that keeps returning to that moment is the same part that kept your ancestors alive long enough to become you. There is a moment you keep returning to. You know that now for what it really is. Not a wound your brain refuses to heal, but a message from the most ancient part of you, still watching, still protecting, still doing the only job it has ever known. The memory will not disappear. But now you know what it is, and that changes everything.